Okay, now we're looking at cycloalkanes. So still alkanes, they'll all have single bonds, but now we're gonna have a closed circle of carbons, some spot in our, and that'll be our parent chain. Okay, so yeah, carbon-carbon bonds and a cyclic hydrocarbon, still single bonded, are cycloalkanes. Okay, our general formula now changes to CnH2n because basically we're closing up that branch, or closing up that parent chain, which takes off two of our carbons, or two of our hydrogens, sorry. Okay, and so for naming these, same thing. Parent chain is still our cycloalkane. So we just find however many are in our circle. Okay, and then we place cyclo in front of it to show that it's a closed ring. Okay, if there are branches, you start the numbering for the location of the branch using the lowest possible numbers. Okay, if there's only one branch, so if there's just a branch coming off of this, we don't need to put a number because really we could just turn that, it'd be the same as if we just rotated it once and it was here or here. So we only need more branches, or we only need numbers if there's more than one branch. Okay, and so for practice here, so provide structural, condensed, structural, and line structural formulas for cyclohexane. Okay, so for drawing these, so again, we have a 6-carbon chain. Hexane means we're going to have a hexagon. Okay, so, and then you'd add in the proper number of H's. So each of these needs 2 H's. Okay, I'm not going to put them all in just because, I struggle using this mouse's drawing tool. Okay, the condensed structural would look exactly the same, except instead of putting these H's, you would just put CH2 for each of those. Okay, so the condensed structural just all have CH2s, and then the line structural, you don't need any H's. You just are drawing a hexagon. Okay, and there'd be a carbon here, at each corner. So we have 6 carbons and the proper number of hydrogens. So this would be our line structural formula for cyclohexane. Okay, if we're naming it, now looking here, okay, for example, so again, this one's out of your textbook. All 3 of these are showing the same thing. This is our structural diagram, this is our condensed structural, and this is our line structural. Okay, so they all have the same name, one name, it's the same thing. So you count how many in the parent chain. So 1, 2, 3, 4, 5. So we have a pentagon, we have our parent, it's going to be cyclopentane. Now we have 2 branches coming off. Okay, so we start our numbering. It doesn't matter, you always start your numbering with one of the branches. So this is going to be 1, this is going to be 2. So we have 1,2 dimethyl cyclopentane would be the name of this compound. Okay, some properties of alkanes and cycloalkanes. So they're the least reactive of all the aliphatic hydrocarbons. Okay, they're nonpolar. They're all nonpolar. It doesn't matter their shape or anything like that. If they only have hydrogen and carbon, they're nonpolar, which makes them insoluble in water. Okay, they are also less dense than water. So if you think of oil spills, how the oil sits on top of the water. Okay, and then alkanes have the lowest melting point and boiling points of all the organic compounds. Okay. In longer carbon chains, the greater number of electrons produces more attraction between molecules, okay, which results in higher melting point and boiling point. So as you add carbons to the chain, it's going to change their temperature. So carbons, if it has 1 to 4 carbons in the parent chain, it's a gas. So methane to butane. Okay, from pentane to, we don't name up to 22, but up to 22 carbons, these are usually liquids, and if they have more than that, they're going to be solids. Okay, so small alkanes, are gases, medium are liquids, and larger ones are waxy solids.